With all the recent well-publicized hacking and malware attacks, not to mention numerous meteorological events that have affected companies around the globe over the last year, IT leaders are well aware of the need for robust cloud security and compliance. Myself, Vidya Andamurli, along with my teammates Jape, Zhang Yuxi, and Zhao Zhanyan, would like to present to you the bolted system for secure cloud auto deployment. First, I'd like to explain why we need the bolted system. Considering an emergency situation and we have 100 nodes on our public cloud and we just want to access 40 nodes out of the 100 and not let the other 60 know that these 40 are being accessed in order to avoid security breaches. So for this case, we are considering isolation services that act like virtual LANs, which could be used for isolation purposes in order to provide high security for accessing that particular public cloud. So what is the bolted system? It consists of 4 components. First is BMI, which is bare metal imaging, which provides provisioning services to the system on the whole, that is by providing operation systems and other services that support software services that support the system. Then we have HIL, which is the hardware isolation layer, which helps in isolation and attestation services of particular nodes. And then we have Keylime, which is used for privacy issues and security issues, wherein there is a TPM that is present in Keylime, which compares the white images of the client and the server and then allows access to the client. Then we have an orchestration engine that helps to support all the working and functioning of these components together and integrates them by creating communication between them. So this is what a bolted system is. Now what our project is going to deliver is an automated installation and configuration process to make this bolted system run together just in one script. Right now what happens is we'll have to install and configure HIL separately, Keylime separately, BMI separately, and orchestration engine separately, but our project focuses on combining, facilitating communication between these components and delivering them as one script wherein a client requests a few nodes and then it would just attest the nodes to the client. So I'd like to put forth our project goal here. First was for the installation process, that is to install all the components, HIL, BMI, and Keylime, and install all of them on a virtual machine. Then to facilitate communication between all these components so that they could at most take in services from what each of them provide. And then the last step would be automation process, wherein we would just run one script and the output would be obtained.
The system architecture is shown in this picture. There are 4 virtual machines here. The blue part explains the Docker environment. The green part is the administrator part. And the pink block is a key of user scenario, which is running the Ansible playbook to orchestrate and control all the virtual machines. Users changes their platform and then execute the installation program. From the user perspective, user runs an installation script from the administrator server machine to deploy all the components and build a system. As the picture shown, all the components are based on the overall system architecture that we discussed in the project overview. BMI server, HIL server, and Keylime server are deployed into separate machines. For now, we have a single node to demonstrate the installation result in this picture. Here is our project plan for each sprint. As the picture shown, almost all our jobs are continued. We have 2 weeks for each sprint, and there are overall 6 parts. We started our project by reading a lot of original materials, and now we finished using Ansible to orchestrate all our components. Here is our Taiga diagram. The top one is our overall project backlog, and the lower one is the backlog of Demo 6. As you can see, we have met some issues with installation and understanding of the topic at first, so the progress is a little bit slow. After talking with our mentor and do a lot of research, we started to make progress gradually. Till now, our product has met all the user stories, and we finished the MVP successfully.
Further ahead, we'd like to put forth our accomplishments for this particular project. Our initial steps were to install HIL, BMI, and Keylime as separate components, and we did that first on our own virtual machines. where we didn't encounter much issues. But when we did install these components on Kaizen, we did encounter issues with Hill, wherein we resolved them by running this server in the background and then running Hill on top of it. So certain things involved a little bit of research and speaking to our mentors. Then we moved on to creating Docker images in order to containerize the three components. So let's take Hill image for now. Considering the fact that Hill has three servers, one is the Postgres database, and then it has the Apache server, which is used for API requests, and then it has the network server, which has network services that it provides. While we tried containerizing Hill, we faced problems with respect to systemd and systemctl and other system service commands, which does not run inside a Docker image. So in order to solve this problem, what we did was we pulled two system images that were already running, that were server images that were already running, and then we used the Apache and the database image that was present and then built the image on top of this. So while doing this, we had HTTP, which was the configuration file for the daemon to keep it running for the Docker image. And then we created communication between the containers. Second, for PostgreSQL database, when we created the container for PostgreSQL, what happened was we always got access denied, permission denied. So this took a lot of our time because we did not know how to resolve this issue. But then later on, towards the end, we did realize that we had to add an entry point to our container, wherein we had to include a small SQL query in order to create our database. Because our issue with access denied was that it wasn't letting us make a new database under the PostgreSQL server. So we resolved this by adding an entry point. The problem was solved, and we got the Hill image running and the PostgreSQL image running on two different containers for our particular project.
So after we finish containerizing Q, we turn to the containerization process for Keylime server and client, which is not easy. During this process, we have learned how to create a subnet for containers and how to scale containers using Docker. But we still suffer from a significant number of problems after this. For example, before we can make sure BMI function properly, we should firstly build a Ceph server for BMI, since BMI rely on Ceph to store user images. Therefore, we proceed to learn the structure and design of Ceph and how to deploy a simple Ceph server on cloud, that is on Kaizen. After we successfully build containers for all the components, we start to think about how to enable the communication between them. This requires us to figure out how to get the dynamic IP address for each component and configure each component inside the container to ensure they know each other well. We make use of Ansible at last to automate the container building job for us. This process includes setting up IP address for all the hosts and deploy containers to them. Then we write a Python script to chain all the parts together. Well, and the general deploying procedure can be stated as this. At first, the user pull our codes from GitHub, configure the user configuration file, and place the Ceph keyring in the certain file. The automation script will then build the Hill container and the corresponding Postgres container. Then it will build BMI container and run it on the user-defined BMI node. Finally, the automation script will take care of the Keylime server and client, automatically deploy them on the target node, and terminate properly.
Yay, demo! Let's show our demo. So we're first gonna show you this 4 different VMs running on Kaizen, and each one has Docker pre-installed. But each image has no containers image and has no containers running. And there's no files in there as well, so we don't cheat anything. Okay, now let's install it. We first pull the repository from GitHub, and once we have the repo, we need to run 2 sh command to allow the user to input their public key password, so they don't have to input it while the installation progress is going on. So after we've done that, we need to configure the configuration file. But we have pre-built a configuration file that's for a demo, so we don't have to input it. Here's the configuration file, and then once we have that, we can run the installation script. What the installation script's doing, it will run all the Ansible playbooks separately. The first one, it will run the Hill installation process, which has going to install two containers. One is for the Hill database, and the other one is for the Hill server. And the database should be able to communicate with the server, so the Hill server is running properly. So once the Hill is running, it will install the Keylime server, and once the Keylime server is running, it will install the Keylime client node, and all these components being installed on different VMs. At the very end, it's going to install the BMI server, which will talk to the Hill server to do future provision. Okay, now all the installation has been finished. Let's show you the result. So what we are going to show you is that all the image has been built and the containers running on each VM, and each VM is running only one component. Here's the Keylime server and Keylime client. So once we have that, we're going to get into the Hills container to show you the Hills running properly by running the Hill command. Boom. Okay, here's our demo. For this release of project, there are still several limitations of the product. The first limitation is that the current deployment environment is using the virtual machine as our deployment environment. For example, the TPM module for Keyline is still using virtual hardware instead of the physical hardware, and Hill is still using mock switch instead of real switch on the rack. Therefore, there's no physical node deployment for this release. Another limitation is that the installation process still takes quite long, which is about 15 to 20 minutes. And the current release only handle deployment of BMI, Hill, and Keyline component without the orchestration engine included, even though it's not included for our MVP for this project, but which can be included for future release. Throughout this project, this is what we have learned. First, we have learned is the virtualization. For example, we use the virtual machine operating system for development and also development under containers operating system as well. We also learn the feature of the system components and how does those components form the secure deployment cloud using BMI, Hill, and Keyline. And all of our deployment and development is using MOC Kaizen platform, which is also using OpenStack, so we have to learn it as well. And we also learn how to use Ansible as our deployment method. So we have to learn how the Ansible playbook works and how to use Ansible to orchestrate all the containers. We also spend a decent amount of time to learn Kubernetes, since we believe that Kubernetes can facilitate our deployment. Even this feature is not included in this release. We also learn how to use the SAP server, which is as a database server for BMI provision. And we also learn the automated installation schematics, which include using Python script, Bash script, and using configuration file. Throughout the project, we constantly learn computer networking to solve most of the problems. For example, how the network protocol works and how the server responds to those protocols. And even the network schematics of the whole system is also what we learn. Since all the developments on the Linux environment, we also learn many about Linux operating system components. For example, how the system service works and how the system daemons work. For our project future perspective, the first part is based on our current release. It should develop and the deployment system for physical hardware instead of virtual machine. And project can automated detect components version update and auto update the system component when new release come out. And more installation customization should be implemented for the project for user to do more customized installation of those components as well. Also, the Baltic can work as a server responding to users' requests through the RESTful API, for example, instead of manually install everything. Okay, thank you for watching our video. Before signing off, we would like to thank our mentors, Amin, Navi, Charlie, and Apuro for helping us complete this project successfully. And we would also like to thank our professors as well, Professor Oran, Professor Ada, Professor Peter, for giving us this learning opportunity. If you like our video, please give us a thumbs up and subscribe our channel. Kuku.